Hi everyone, I am Nikhil Mittal. Welcome to day 2 of week of continuous intrusion. We will discuss TeamCity today. TeamCity is another widely used continuous integration tool, and like Jenkins, it has its own set of security issues. For example, TeamCity provides guest access by default, though it could be disabled, but by default it is enabled. Guest access allows a user or a guest with project developer privileges that are those are view privileges. Other than that, TeamCity does not have any password policy as well, no password complexity or password history, but it does have protection against brute force attacks. So if you try to log in consecutively for 5 times with wrong username and password, it will lock the user for 1 minute. Another issue is yet again the TeamCity server and agents run with system privileges on Windows. Another thing is it allows for registration of new accounts. So these are some of the things which some of the security issues with TeamCity. For example, in this TeamCity on my local machine, I can log in as guest, and guest user can see quite interesting things. For example, now, when we brute force Jenkins, or to brute force anything, the first step is to be able to enumerate users. So with guest privileges, we can enumerate users to a good extent. We just need to go to this URL with the privileges of a guest. So there is no build with ID 1. With ID 2, we have a build. And what we need to look here is the user who triggered the build. So if it is an automatic build, then I think the username would be changes here. So we need to discard that. Otherwise, we can just go through these IDs and look for the users who triggered these builds. Also, uh, TeamCity, if you see here, I think I have a request here. If you see, TeamCity sends password in encrypted form, so it is not possible to brute force it from the login URL like this one. But if we go to if we use its API, I think I will have one there as well. If we use its API, it provides for the basic authentication, so we can brute force it using using its API. So we have enumerated the users, and then we can brute force it. So if you see the blog post for day 2, it has been well explained there. I'm not going to go into this in the video. So we because I'm not going to go to that thing in this video, let me just log in with a low privilege user which is a non-admin user, but it has the privileges of configuration configuring builds or editing builds. So like other CI tools, TeamCity has the capability of executing commands on the OS level. So let me just quickly show you this. So here is how we can do it. I'm just adding either I can add a build step with the PowerShell runner, or I can edit the existing one. So let me just copy this. I'll show you this as well. So if I run who am I here, save it, and now if I run this, in the build log, you can see that it runs with the system privileges. So which is as an attacker, which is good for us. So once again, we have access to something which provides us with system level privileges on many machines. Now I would again like to highlight the power of PowerShell here, because we are running this on a Windows machine. The PowerShell toolkit for penetration testers, Nishang, which I maintain, it contains a very good reverse HTTPS shell called invoke posh ret HTTPS. We can use that with this capability of executing commands. That shell provides a completely encrypted valid HTTPS session between the target and the attacker. So let's just quickly use it. So we are loading invoke posh at HTTPS. We want to listen it on this IP on this port. We have the listener on. Now the best part with invoke posh at HTTPS is it has a very small client part. We just need to execute this on the client. So let's just copy this and let me edit this. I'll just paste it here, save it, and now if I run the build, I shall soon have a connect back from the target machine. So we have a connect request from this remote IP, and we are running as. Note that sometime you need to provide multiple commands to this shell, as the smaller commands are generally lost in the encoding. I'm still looking into that. So we are running as system, and we can run PowerShell commands as well, which is quite neat. This is a completely valid HTTPS traffic. So once again, PowerShell improves our existing techniques. So we can always just exit it now. Now, a couple of more things with TeamCity are, like all other CI tools I tested, TeamCity stores SSH keys in clear text on disk, which is disastrous if you ask me. So let's just quickly see a previous build. What we ran here was, okay, let me show you what I ran here. So we just needed to read SSH keys from the data directory of TeamCity. So this is the TeamCity data directory, which we can see from the previous build logs. And from in the data directory, config projects, the project name, and plugin data, SSH keys. And we are reading everything inside the SSH keys directory. And the result looks quite scary. We can see even the private keys are being stored in clear, so which is very bad. Another interesting thing with TeamCity is a user called the Superuser. A Superuser, according to the TeamCity documentation, it is a user which could be used to reset admin password or things like that. So it is supposed to be used when you cannot log in as admin or you forget the password. Note that one thing I forgot to mention, that in case of SSH keys, in case of command exec, we had the capability of configuring builds on an agent, but in case of SSH keys, we need capability of configuring builds on master. Similarly, for Superuser, actually we can read the token of Superuser from if we have the capability of configuring builds on master. And how can we do that? We just need to read the TeamCity server.log file from the TeamCity installation directory. We just need to read from this file, and what we need to read is superuser authentication token. So if I run this, and if you see the build log, the latest one is the valid token for superuser. So this is the token for superuser, and the log says to log in as superuser, use any empty username and this token as a password. Very convenient. So let's just use it here. And as you can see that we are logged in as superuser. We can do a lot of stuff which we could not do as the config user. We can change authentication methods, manage users, and a lot more things. Change agents, environments. There's a couple of interesting things about superuser. Uh, any number of super users can log in simultaneously, and the superuser token is changed only when the TeamCity TeamCity server service is restarted. So if you get your hands onto a superuser token in production, then it is a reasonably medium to long term method to get back into that system. Another interesting fact about superuser is this. Let me show you there. On a blank login screen, if I press login 5 times, due to the brute force protection thing, I can lock the superuser for 1 minute, which which is obviously noisy, but it is interesting to be able to do so. So now even if I have a valid token, I won't be able to log in until 1 minute is over. So this was another issue with TeamCity. If you go through the blog post, there are Google Docs which allow one to locate public instances of TeamCity. So many of them provide guest access or ability to register a new user account. In both the cases, we get project developer privileges, which are view privileges, but those are good enough to at least enumerate users. So enumerating users is the least thing you can do with them. If you go through the blog post, I have screens there. I was able to locate, for example, uh, a product which was under development, its URL and admin and test credentials were dumped into the build output of TeamCity. So you can just use that. I also saw database credentials there, email IDs of developers, or a lot more things. I mean, TeamCity, like other CI tools, the console outputs or build outputs of these CI tools, those are of great value, and there may actually be no need to compromise TeamCity itself. You can scrap enough information from its build outputs as a guest or a guest account or a new account, and you can compromise so many parts or so many information from a target without even having to break into TeamCity just from its build outputs. Uh, about that Java unserialization vulnerability, as far as I know, TeamCity does not use the vulnerable common collections class, common collections library. So I don't think it is vulnerable to that. So I believe that is all for day 2. Hope you enjoyed the video. Have a good day.